Okay, in this video, I want to go over more. We talked about equivalent fractions, so we should be able to take fractions that we need to create common denominators, and through equivalent fractions, we should be able to get those denominators the same. I'm going to just use some examples for you. One, just fraction and fraction, improper fraction, and then mixed numbers. So let's start off with something like 1/3 plus 1/4. My denominators are not the same, so I have to get them the same. I'm going to use the stacking method that we use because I do think that's the most effective way to do this kind of a problem. So if I take 1/3 and I'm going to add it to 1/4, my issue with this, first off, is the denominators are not the same. I cannot add them. So what common denominator can I use that I can get 3 to and that I can get 4 to? And you should say 12. I can get 3 to become 12, and I can get 4. This way I will have the same common denominator, and then I can add them. So what would I have to multiply 3 by so that I get 12? You would say 4. And remember, when I'm creating equivalent fractions, it has to be multiplied by 1. And also, I've said before, whatever you do in the denominator, you must do in the numerator. So you see that I'm going to multiply 1/3 by 1 so that I can get the denominator of 12. So 3 times 4 is actually 12, and 1 times 4 is 4. So my equivalent fraction for 1/3 to get the denominator of 12 would be 4/12. Down here, I would multiply 4 times 3 to get me to 12. And whatever I do on the bottom, I do on the top. And 1 times 3 is 3. So now by creating equivalent fractions for 1/3 and 1/4, I have a new problem to where now my denominators are the same and I can add them through. So 4/12 plus 3/12 would give me 7/12. And that would be my answer, 7/12. So 1/3 plus 1/4 is 7/12. And you can see that there's no way I can add these together to get that unless I find common denominators. And in this case, between 3 and 4, it was 12. I could get them both to 12. And if you notice, some of you like this. If you notice that my one denominator is 4 and the other one is 3. And if you see what I did with 1/3 is I basically took this denominator and put it as 4/4. I used that number 4, and then I used this number 3 down here because 4 times 3 is 12, and 3 times 4 is 12. So if I utilize each denominator and create 1 with it, then I can go ahead and I will always have the common denominator. So if you're ever stuck, so let's do one like that, just so you know, because that applies for any fraction. Let's say I have 2/3 plus 1/5. And maybe you're stuck. Well, I don't know what number 3 goes into that 5 also goes into. So let's go ahead and stack them and do our 2/5. Oops, I'm sorry, that's 2/3. Let's do our 2/3 plus our 1/5. Okay. I don't know what each of these goes into. I'm just going to pretend I don't know. I don't know what number it is. So if I'm stuck, let's just do this. Well, I know that 5 times 3 is 15, and I know that 3 times 5 is 15. So I could multiply this by 5/5. So I basically took him and utilized him in that manner as 1. And I would get 10/15. Okay. And then if I want to get him to 15. Well, I know that 5 times 3 is 15. So I could take him and multiply him by 3/3. And I would get 3. fifteenths. So once I add those together, 10 fifteenths plus 3 fifteenths is 13 fifteenths. And that would be my answer. So 2/3 plus 1/5 is 13 fifteenths. And you can see there's no way I can do that unless I get common denominators to carry out that operation. This is for fractions, it's for mixed numbers, and it's for improper fractions. Doesn't matter. Okay, so if I had an improper fraction plus an improper fraction, say 7/5 plus 3/2. You can see that these are improper. Improper fraction, meaning my numerator is bigger than my denominator, which tells me that this fraction is greater than 1. I have an excess of, it's no longer a fraction. A proper fraction would be like 1/4, where my numerator is smaller than my denominator. Works exactly the same way. I can't add those until my denominators are the same. So I'm going to take my 7/5 and I'm going to add to my 3/2. Okay. I'm going to stack them. Then I'm going to go ahead and create equivalent fractions so they both have the same denominator. And if I have a 5 in this denominator and a 2 in that denominator, my common denominator, can get them both to, would be 10. So in order for me to get him to 10, I would have to multiply him by 2/2, because 5 times 2 is 10, and then 7 times 2 is 14. So my equivalent fraction for 7/5 is 14/10. Down here, I need to get him to be 10, and I can do that by multiplying 3/2 by 5/5. Because 2 times 5 is 10, 3 times 5, 15. So 14 tenths plus 15 tenths would give me 29 tenths, and that would be my answer. So it doesn't matter if it's an improper fraction or a proper fraction. If my denominators are not the same, I have to get them the same through equivalent fractions. Now, if we're talking mixed numbers, so if I have 3 1/3 plus 1 1/2. Now, I obviously can add 3 and 1. It gives me 4. But I have a problem when I get to my denominators. They're not the same. So I'm going to stack them like I normally would. So this would be 3 1/3 plus 1 1/2. All I'm doing is taking this from a horizontal problem to vertical problem. Now, if you notice, my denominators are different. I'm going to get them the same. What number can I get 3 and 2? Can I get them both 2? Or what common number do they both go into? 6. So I would multiply him by 2/2. Now, remember, when we're multiplying that, we're only multiplying to the fraction. So my 3 just carries over, and then I carry out my equivalent fraction process for my fraction. 1 times 2 is 2. 3 times 2 is 6. So my equivalent fraction for 3 1/3 is 3 2/6. Now I want to get him to 6. So I would multiply him by 3/3. And remember, only the fraction is getting multiplied. My 1 will just carry over. And then 1/2 times 3/3 would be 3/6. Because 1 times 3 is 3, 2 times 3 is 6. So now you see that my denominators are the same. I can carry out my whole addition problem. 3 plus 1 is 4. 2/6 plus 3/6 is 5/6. So from my original problem, I stacked it. I created equivalent fractions so that I have a common denominator. and then I can carry out my addition problem, and I'm done. It doesn't matter whether it's a mixed number, an improper fraction, or a proper fraction. I can't add, I can't subtract, I cannot compare until my denominator is the same. So basically, I can't do anything until I get those denominators the same. And I can get them the same by creating equivalent fractions. And that's the goal. So you should know from watching my equivalent fraction video and watching this that you can do that. Okay, so remember, that is a golden rule. I'm never going to add my denominators. I'm going to get them to have the same size pieces, the same number of pieces, and that way I can add them, subtract them, or compare them. Works with subtraction as well. Same process, I would just be subtracting the numbers rather than adding them. I hope that helps.